Hope you guys are doing well. We're going to move on today. We're going to talk about the bell ringer. We're going to use the bell ringer. We're going to go and talk about hearing and how we sense hearing and how we perceive it. Before we get there, I want to get to the bell ringer, obviously. Vocab. Make sure you guys have your vocab turned in for Friday. I'll make sure I put up a message on the announcement for today to remind you that vocab is due. And I'll keep you posted on a quiz yet. I don't know. I'll probably have something on vision, hearing, how we perceive those types of things, and a couple vocab terms for you. But I'll keep you posted on that. That being said, we're going to move on with sensation and hearing. But before we get there, here's the bell ringer. Pull this up for you. So describe the electromagnetic spectrum. Within your response, label what frequency, amplitude, and wavelength is. There you go. If you want to, please pause the video. Okay, I'll give you a few seconds to do that so you can fill out your response. Okay, electromagnetic spectrum. I'm going to pull up a diagram here so it's easier to understand. Okay, so this is from the slides, obviously. And with electromagnetic spectrum, there's only a certain small part that we can actually visualize, which is interesting to say the least. There's only a certain wavelength, frequency, amplitude that we can actually detect as light. And obviously this chart is pretty big, as you can see. Let me see if I'm presenting. Okay, good. So with the light spectrum, obviously with red, we're going to have a longer wavelength, okay, which is going to be a shorter frequency, okay? And then obviously once we get to purple, we're going to have a shorter wavelength with a larger frequency. And that's how we can visualize different colors. And that's how, again, like I mentioned yesterday, there's actually no colors on the items that we see. It's just how light bounces off and reflects off those items that we visualize that certain light. And with this electromagnetic spectrum, it's large, it's huge, and there's only a certain part that we can actually visualize and see. All right, so at the far right with the largest wavelength, okay, it oftentimes is as large as a football field, 100 yards, if you believe it. That's radio waves, okay, radio waves where that's obviously sent out through different broadcasts. We can't visualize it, we can't see it, but with these radio waves, that allows us to hear broadcasts. Obviously with the radio, different types of sound that's projected from, let's say, a movie screen. Okay, there's a lot of different things that's used for with sensing sound, things like that. And then we'll move to microwaves. Okay, microwaves, obviously, it's a shorter, wavelength, a higher frequency, which we'll talk about here soon. And that is obviously used to heat up food, things like that. And that's right next to what we know as infrared rays, which is used for heat. Okay, obviously we can't see it. We can't visualize these sort of wavelengths or versions of light, but we can feel it. Okay, we can hear it, things like that. And with the infrared rays, that is obviously even a shorter wavelength. It's getting shorter and shorter as you move left on the electromagnetic spectrum, and the frequency is going to increase. That means there's going to be more wavelengths to it. Okay. But the wavelengths are getting shorter and shorter and shorter as we move to the left. And then obviously we know as what we can visualize, what we can see, okay, it almost looks like a rainbow all the way. If you shine the light off a prism, that's what you see. And rainbow in the sky, same thing, okay, depending on what we visualize with the different types of elements environment. Okay, next, moving left, which is even a shorter wavelength, a higher frequency, is ultraviolet rays. Again, we don't see those things. Okay, it's something that we can almost feel as heat as well, and it's something that after some time could damage us, obviously, because of the intensity of that light. Okay, X-rays. All right, same thing. As we move left, wavelength is going to decrease, right? And the frequency is going to raise. That means there's going to be more waves, okay, with a shorter wavelength, but it's going to be more waves. And obviously we know what X-rays are for. We can visualize things through skin, see the bones, okay, different things like that, and help us understand what may be wrong with us if we got injured somehow. Okay, and again, too many X-rays could harm your body because of the intensity of that light. All right, next, gamma rays. Okay, this is almost as small, these wavelengths are almost as small as a atom in our body, which is crazy. Well, any atom, obviously, but if you think about it, the gamma rays are very, very tall or very small. Frequency is really, really high. Obviously, you get that, you're going to be hurt, right? Too much of these rays. And with the gamma rays, okay, the wavelength is so short, it's as small as an atom. And then obviously that's totally different from what we talked about with radio waves at the far right of the electromagnetic spectrum, which is long as football fields, right? And then after gamma rays, it's not on there, but they're cosmic rays. Right? I know what you guys are thinking of, especially you, Rooster. You think about cosmic energy, you're thinking about gamma radiation, you're thinking about the Incredible Hulk, things like that. I know, but calm down. It's okay. All right, so that's the electromagnetic spectrum. Far right, radio waves, we're moving in, microwaves, okay, infrared, what we can actually visualize, okay, as the electromagnetic energy and through a prism, the rainbow color that we can see, ultraviolet rays, X-rays, gamma rays. And as we start on the far right, okay, these wavelengths are longer. It's a lower frequency, okay, of things. And as we move left, the wavelength is going to decrease, right? And the frequency is going to be higher. That amplitude is going to be a lot higher. And again, there's only a certain part we can actually see and visualize in that electromagnetic spectrum. So make sure you guys know that. It's definitely going to be probably on a quiz. So make sure that you really look over that and understand it. That video should have helped you from yesterday. All right. So real quick. All right, so I can explain it here. So these are wavelengths here and how we can visualize high-pitched sounds, what we can see, what we can visualize, all right? And with the wavelength, this is what I'm talking about. A wavelength is this area right here, obviously between waves. Okay, it might be larger, right, longer, it might be shorter, okay, depending on what we're visualizing. As you can see here with red, since it's on the far right, these wavelengths are going to be wider, farther apart, okay? And as we get closer to purple, right, these wavelengths are going to be closer together, right? And as we see here, so wavelength is the distance between the peaks of the waves, right? Amplitude is, so let's just imagine there's a line right through here, okay? The amplitude is the peak of the wave to pretty much the line in the middle, okay, where that's going to be located. And that's going to help with pitch, right? That's going to help with different types of dull sounds, dull colors, right? And as obviously you get farther to the left-hand side where we get to darker colors like blue, purple, okay, that's going to be a higher pitch sound because the amplitude's higher, right? And that's going to be to a point where these colors are going to be darker, like a purple, bluish color. All right, and obviously with yellow, very close to green, things like that. All right, next thing, let me just, I wish we could have done that experiment. It is what it is, though. All right, so this is kind of what I wanted to get at here. The wavelength, all right? The wavelength here is between the two waves. Amplitude is how high that wave is, okay? And that's going to help with pitch. That's going to help with dull, bright colors, depending on how high that is or how low that is, how close it is to, let's just call this equilibrium. All right, and frequency, real quick, frequency is the start point to the end point. And the frequency, if there's a low amount of waves, let's say as a radio wave, it's going to be a further distance from the point or the peak of the wave. That's going to make it obviously a lower frequency, okay, if that's further apart. All right, and that's going to be if it's a stronger wavelength, right? If it's a a shorter wavelength between the two peaks, that frequency is going to be higher, right? So again, at the far right, we'll have further wavelengths. The wavelengths are going to be longer, further apart. And as you move to the left-hand side, where gamma cosmic rays are, the frequency is going to be a lot higher, because these wavelengths are going to be closer and closer together. Like I mentioned before, it's going to be almost the size of an atom. Okay, on the far right, the radio waves is going to be like as long as a football field. Okay, so there you go. There you have it. That should be easy for you to understand there. Oh, here you go. There you go. So frequency, number of cycles completed by a wavelength, given amount of time, amplitude, physical strength of wave, the volume of the sound. Okay. All right. Okay, so real quick, we want to talk about hearing. All right, so how we understand and perceive hearing. So this is really not a hard process at all. It's just understanding, the different parts, the anatomy of the ear, and how this actually works. So our ear is actually formed to really receive sound waves. Okay, the shape of it is almost as like a funnel into our ear, and allows us to really pick up and understand what sounds we're hearing. And really, it's just almost like an adaptive trait that we've gained over time to visualize or to understand and hear certain things to help us survive in our environment. Okay, obviously with animals, a lot different. Their hearing might be increased. It might be advanced to a point. Like obviously with cats, dogs, you name it, their ears are to a point where they can hear things from further distances. Okay, they can hear even lighter sounds, things like that. All right, so the middle ear transmit the eardrum's vibrations through a piston made up of 3 small bones. Okay, this is not the scientific names, but this is what I kind of want you to know. Hammer, anvil, and stirrup. Okay, so as the sound waves are coming through your ear, which my ear, I don't know how that's going to work. It's a little different. But the sound waves comes through the ear, travels down the ear canal, and it hits, obviously, the eardrum. Okay, the eardrum is almost like a funnel in a way. And that funnel will accept and receive these vibrations, the sound waves coming in your ear, as your ear is funneling that into the eardrum. And this eardrum is almost bouncing. Okay, it bounces. It's a membrane that bounces, which is connected to the 3 bones of the middle ear, the hammer, anvil, and stirrup. Okay, as that eardrum is bouncing, as it's receiving sound waves, the bones of the middle ear vibrates, it moves. Okay, obviously, depending on how high pitched the sound is, how loud it is, whatever it might be. And that is connected to the cochlea. The cochlea is this weird looking figure here, right? It almost looks like a snail in a way. So the cochlea is a membrane that receives and is connected to the bones of the middle ear, which bounces, okay? The bones of the middle ear is over here. So the bones of the middle ear bounces and vibrates from the sound waves coming in and hitting the eardrum. Okay, that membrane, and it's connected to the bones of the middle ear, which vibrates and bounces, which connected to the cochlea. And as the cochlea is bouncing and vibrating, there's fluid inside the cochlea. And the cochlea, as it's vibrating, it's connected to a membrane, where the membrane will then send those neural messages to, they call it the basilar membrane, their hair cells. Okay, as the hair cells vibrate as they move, and as they are connected to the fluid liquid inside your cochlea, okay, as those hair cells are bouncing with that, that sends it sends an impulse. It sends a neural message to the auditory nerve, which very similar to what we have with vision. Okay, that auditory nerve is going to send that information as a neural impulse to the temporal lobe. So rather than the occipital lobe with vision, the auditory nerve is going to send that information to the temporal lobe, where we can process, we can perceive what we're hearing. And it's interesting because we're doing this at a fast, alarming rate. Same with vision, hearing. Okay, we'll talk about taste, touch more tomorrow. But it's interesting how fast that actually works and how that vibrates to the point where we can process this information in our brain in seconds, milliseconds, right? It's amazing how quick and fast that works. All right, so there you have it. So again, sound waves comes through the ear canal, vibrates off the eardrum, hits the 3 bones of the middle ear. 3 bones of the middle ear is going to vibrate the cochlea, which is connected to, and this is going to vibrate the fluid liquid within the cochlea, which is going to interact with the membrane, basilar membrane, where the hair cells are connected to. And the hair cells are going to send a trigger, an impulse, a neural message to the temporal lobe, where we can perceive and understand what we're hearing. And this is kind of what it looks like. This is a better obviously chart. So come through here, eardrum bounces, hits the 3 bones middle of ear, vibrating off the cochlea. All right, the cochlea is then going to send that information through, the different types of, membrane. Okay, the liquid interacting with the hair cells, which is going to send a neural impulse to the auditory nerve. The auditory nerve is going to send it to the temporal lobe, which we know and understand. Okay, there you go. I hope you guys got that. That's all I wanted to go over today. And I will send out along with the lesson here, information about the anatomy of the ear and how that works, how we perceive sound. All right, take care, guys. See you.